Alright, calculus, we're here with a video looking at the fourth section. We're looking at the algebraic method to deal with limits. Algebraic means no calculator necessary. Necessary. Can I even spell that right? I don't know. Who knows? We don't need spell check either, apparently. So, let's get started. Finding limits algebraically, we're looking at classwork. So here's kind of like the general ideas. We just plug in. And if we get something that says 0 over 0, then that tells us that there's something on top and bottom that's going to reduce out. And then after that, we try and see what happens or what's left over. We're either going to get a number or some type of number divided by 0. And whenever we get to this, we're going to be dealing with something that has to do with infinity. We'll get to that in a little bit. Let's start with just the basics, which is plugging in a value. So this first one, you can do this by plugging in. So I'm telling you right now, and so is Stu Schwartz, the guy that created this stuff, that you can just plug in. In other words, this value, x equals -2, is just going to be plugged in to x here and here. We're shortcutting. Instead of looking at the limit as x approaches something from the left and the limit as x approaches something from the right, and seeing if those are equal, and then if that leads us to saying, well, then that means the limit exists as x approaches whatever that value is. Instead of doing all that, we're skipping it and we're just plugging in the value right here. So we're going to check. We're going to see if it just works, or do we have to do some different approach? Do we have to take a different path to get there? Well, we plug in this one. -2 squared minus 4 times -2 plus 1. That actually works. This is 4 plus 8 plus 1. So the limit as x approaches -2 of x squared minus 4x plus 1 equals 13. These three things right here put together. So no problem. Check. Move on. This next one, if I plug in -2, let's see what happens. The limit as x approaches -2 of 2 times -2 minus 6 over -2 minus 2. Well, that's just -10 over -4, or 10 over 4, or even more simplified, 5 over 2. Check. No problems. All right, now let's look at what we would do when we get problems. This third example here. If we were to plug it in, we would get -2 squared minus 2 times -2 minus 8. That's 4 plus 4 minus 8. That's 0. And then for the denominator, that'd be -2 squared minus 4, or in other words, 4 minus 4. That equals 0 too. So we'd have the 0 in the numerator and 0 in the denominator not working for us. That means we got to do some fanciness. We got to factor. Fancy factory. The limit as x approaches -2. Now we can factor each of these pretty simply. You know, the top has two pretty basic factors, and so does the bottom. The top you can work out with diamond factoring if you need to. What multiplies to -8 adds up to -2, and that gives us -4 and +2. So this would be x minus 4, x plus 2. Then the bottom is just a difference of squares, because 4 is really 2 squared. That's x squared minus 2 squared. So that's going to give us x minus 2 times x plus 2. This helps us because once we can see x plus 2 over x plus 2, that's really just simplifies to 1. So we're just left with this piece here. Once we've done that, let's try plugging in again now. If we plug in -2 into the top, we'll get a number. If we plug in -2 to the bottom, we also get a number, not 0. As long as it's not 0, we're fine. So plug it in. That's going to be -2 minus 4 on top, and on bottom it's -2 minus 2. Altogether, that's going to be -6 over -4, simplified even more, is 3/2. So there's your value. Let's take a look at this one. It's similar. Not exactly the same, but similar. we might have to talk a little bit about how to factor this beast here. Well, let's start with the top. I see that x squared minus 2x plus 1 is actually not too hard to factor as x approaches 1. Oh, well, first, it's telling me that if I plug it in, I get 0 over 0. So I'm going to skip that part and just go to the factoring. The numerator would factor, in this case, to x minus 1 times x minus 1. You could just say x minus 1 squared. Sure. I like to write out the factors. Why? Because sometimes these things reduce, and when they reduce or when they simplify, you don't want to miss something. You want everything to be out there in front of you. Now on the bottom, I can factor this one as well. And I actually know from factoring cubics, a difference of cubes, this is going to be x minus 1. Then we'd have an x squared, 1 squared, and in the middle we'd have minus 1 or plus 1x. And this is a plus as well. Once we're at this point, that x minus 1, that's going to factor, or that's going to simplify. X minus 1 over x minus 1, that's just 1. Now I have on top and bottom two new factors. If I plug in 1 on top, I get a 0. If I plug in 1 on bottom, I don't. So I'm okay. I can just do that. I can just plug in 1. That means I'm going to have 1 minus 1 over 1 squared plus 1 squared, or just plus 1 again. So it's really 0 over 3, or simplified even more, 0. Now, again, when you're looking at this whole idea of factoring cubes, you can always look that up in the patterns with it, but we were doing a factoring, a difference or sum of cubes with this denominator. That's what helped us get to these two factors here. Let's take a look at the next ones. Oh, I had more space. I should have used it. Let's keep going. All right, so just to refresh, we have this idea. First, we're plugging in. So you plug in. And if it's 0 over 0, then that means that's indeterminate. It's an indeterminate form, or in other words, it's a mystery. And if it's a mystery, that means we got to do some algebra. So then we do some algebra. Now, as long as it's a number over a number, and this denominator is no longer 0, then we're done. Done dizzle. But let's say it's still over 0. If it's a number over 0, that's actually something to do with infinity. That's going off to something, it's either positive or negative infinity, depending on the other values around that. So we got to look at, now we got to look more at each side of the limit. So let's just put that into practice. Let's see what's going on. So we see this one. If 1 and 2 do not work, in other words, we're still having a 0 in the denominator, then it's going to be one of these options. Either it doesn't exist, it's infinity, or negative infinity. All right. Pardon me. So I plug in 2. If I were to plug in 2, you get 9 over 0. 2 times 2 is 4 plus 5, that's the 9. 2 minus 2, that's a 0. No good. Now, we can't factor that. I mean, you could try to do something, but it's not going to do any good. So we know that it's either infinity, negative infinity, or does not exist. Let's see what happens. Well, we got to check the left side and the right side and then see what's happening in the middle. So if I'm going from the left, that means it's the limit as x approaches 2 from the negative side of 2x plus 5 over x minus 2. Now, let's just imagine we have numbers to the left of 2. That's the left of 2. So what's a number right on the left side too? How about 1.9? So if I were to plug in 1.9 here and here, just for argument's sake, what kind of things are happening? Well, the top, 2 times 1.9 plus 5, that's a positive number. And on the bottom, that's going to be a negative number. And a positive divided by a negative is equal to a negative. Now we know that when a number is divided by something really small, really tiny, that it goes off to infinity. And if you don't believe me, try it in your calculator. Take a number and divide it by something really small. I mean really small, like 0.00000000000000000000001. When you do that, you get something really big. So this here would be negative infinity because we got a positive number over a negative number and it's going to infinity, but it's going to be negative infinity from the left side. Well, let's look at the right side now. From the right side, we're going to use the similar technique, but we're going to look on the right side of 2. So that means the limit as x approaches 2 from the right. And if we're doing that, let's pick a number that's on the right side of 2. How about 2.1? So that means we're looking at like 2 times 2.1 plus 5 over 2.1 minus 2. Well, the top is still going to be positive, but this time the bottom is also positive. So we're going to infinity, but it's going to be positive infinity. So this is what it looks like visually, if you were to think about it. Here's our graph. We're at 2. And on the left side, we're going down to negative infinity. I don't know where is this? This is like, if I were to plug in 1, what would I get? Negative number somewhere down here. Okay, so it looks like we're going to have off to negative infinity. It's going down at 2. But on the right side, it's going up. So what happens when your limit doesn't have any connection? It's not going toward the same direction at all. They're not, these two sides aren't really kissing, you know, they're just kind of missing each other. So then we say does not exist because the left does not equal the right. Never did, never will. Let's keep moving. Okay, find the limit as x approaches 0 of 4 over x squared. So again, you plug it in, you get a number over 0. Now that should imply, it's some type of infinity. We don't know which one. We can't factor or cancel or reduce or simplify anything, so it's got to be one of these. So let's look at the left and the right. Let's start with the left. So we got the left side. Left of what? We're looking at 0. Left of 0. So left of 0 is going to be the limit as x approaches 0 from the left. That's what that negative sign means, of 4 over x squared. Well, something that would be on the left side of 0 is going to be like negative 0.00001, I guess you could say. If I were to plug that in, this would become, this is approximately, 4 over a positive point. Now we got a bunch of zeros in here. This. But the key thing to really recognize is that it's going to be positive on top because that 4 stays positive. And the bottom, because it's squared, is also going to be positive. So that means that we're going off to infinity, just like before. And it's a positive over a positive. So that makes it positive infinity on the left side. Let's look at the right. If we're doing the right side of 0, we're doing pretty much the same thing except just not negative. So x is approaching 0 from the right side. This time we're not going to plug in negative 0.001. We're going to have 4 over x squared, and this is going to be probably positive 0.00001, whatever we got going on there. Oh, this needed an extra 0 in there, by the way. Anyways, is that enough? Yeah, I think it is. Okay, so now we're looking at this, and this is going to be approximately 4 over still positive 0.0000000001 kind of thing. So it's really a positive over a positive, and it's going to positive infinity and beyond. So we have some commonality here. Positive infinity, positive infinity. You put these together, the left side and the right side are both going up to infinity at 4 on the graph. I don't know what the graph really looks like, but I know at 4 that they're going up, up, and away to infinity. So what's the limit as x is approaching 0? Not at 4. My goodness. At 0. So what's the limit as it's going to this place? It's positive infinity, which really isn't a limit. It's like an oxymoron, so it's not really existing. But if you were to give it some type of description, it's convenient to say positive infinity. All right, let's look at some more that's similar. Not exactly the same, but still similar. All right, this one. We plug in 3 to the top, what happens? We got 3 squared plus 2 times 3 minus 3. Oh, that's a negative 3, pardon me. Negative 3, that matters. All over, and then we got negative 3 squared plus 6 times negative 3 plus 9. Okay, so on top we're going to have 9 minus 6 minus 3, which is 0. On bottom we're going to have 9 minus 18 plus 9, which is 0. When you have a 0 on top and a 0 on bottom, which you really shouldn't, right, because that's not doable in math, but that means we can factor. Now, that was almost obvious. The way things are going, you know that this is going to factor. But now I know that I can for sure, because 0 on top, 0 on bottom actually means there's something called an extraneous solution, meaning that something on top and something on bottom is going to simplify. It's going to have a common piece. So let's look at it. The limit then, as x approaches negative 3, now I know this factors. The top would factor to x plus 3 and x minus 1. The bottom, we need to multiply to 9, add up to 6. That's just x plus 3, x plus 3. All right, so we got x plus 3 and x plus 3. Those reduce. We're left with just this piece here, x minus 1 over x plus 3. So now let's plug in and see what happens. On top, we're going to get a number, negative 3 minus 1, which is negative 4. On bottom, we're going to get negative 3 plus 3, which is a 0. Now, of course, that's not really an existing number, but it is going to be some type of infinity. So we got to check the left side and the right side. Well, let's do it just like we did with the other ones. So the left side, that's going to be, we'll do this in red again, the limit as x approaches negative 3 from the left. Now we've simplified this down to just x minus 1 over x plus 3. If we're looking on the left side of negative 3, that would be something like negative 3.1. Well, if I were to plug that in, on the top it's going to be negative, and on the bottom it is also going to be negative. So when I plug those two things in, negative over negative, that's going to simplify to positive infinity. Now again, we're not really talking about actual numbers because infinity is not a number, but good enough for now. Okay, let's check the right side. I bet you guys are guessing it's not going to work the same. That's what I'm guessing. X approaches negative 3 from the right. We have x minus 1 on top, x plus 3 on bottom. And if we're going to look at this, something slightly bigger than negative 3, let's say like negative 2.9. On bottom, we're going to have a positive, and on top, we're going to have a negative, which means this is going off to negative infinity. So we have some disagreement here. We got a positive infinity and a negative infinity, which means the limit does not exist. All right. Keep on rolling. Keep on keeping on. All right, let's look at this piece. Oh my gosh, cubic. Wow. Those are hard to factor. In fact, you could factor this one by grouping, but I don't want to do that, because I want to use some other problem-solving technique in here. So let's look at what we got going on in the numerator. Maybe that'll help give us some type of clue. I do know that if I plug in 2, I'm going to get 2 times 2 minus 4. That's a 0 on top. And on bottom I'd have 8 minus 24 plus 24 minus 8. So I'd have a 0 on bottom if I plug in 2. So 0 over 0 implies to me that's going to be the limit as x approaches 2 of something factorable on top and bottom. Probably going to be something like this. So we'll get to that, but let's see what those pieces would be. Oh, looks like we got a straggler here. Let's cover it up. This piece, boom, gone. All right, so we got to factor this. I noticed that on top that I would have the limit as x approaches 2. On top I can pull out a 2 and have x minus 2 left over. That tells me that most likely there's an x minus 2 down here as well. And then I just got to figure out what's the rest. Well, let's go ahead and start with that. So if I have x minus 2 is going to factor out of this cubic, that means that x minus 2 should divide evenly into it. Well, we have x cubed minus 6x squared plus 12x minus 8. So I'm going to do some polynomial division. Let's see, how many times does x go into x cubed? That would be x squared. X squared times this binomial, or this little term out here, would be x cubed. X squared times negative 2 is negative 2x squared. Then just like with any division, we're going to take that and subtract it from the piece above it. We get a 0 here, and then negative 6 minus negative 2 is going to be negative 4x squared. Now we pull down this plus 12x. X goes into negative 4x squared minus 4x times. And when I multiply that back, it's going to give me negative 4x squared. And then negative 4x times negative 2 is minus 8x. Is that correct? No, positive 8x. Now I'm going to subtract those two rows. And I'll get a 0 here. 12 minus 8 is 4x. And then we got a minus 8 over here. How many times does x minus 2 go into that? Well, x goes into 4x 4 times positively. 4 times x minus 2 is 4x. And then 4 times negative 2 is negative 8. Hey, look at that. Magically, we have no remainder. So that means that these two are my two factors. This other piece here is going to be x squared minus 4x plus 4. So I have all that work there. Let's go ahead and continue this down here. This means that we have the limit as x approaches 2 of 2 times x minus 2 over x minus 2. Now, something that I'm seeing is that this quadratic function here also factors. What multiplies the 4 and adds up to negative 4? Negative 2 and negative 2. So it's going to be x minus 2 times x minus 2 times x minus 2. That's interesting, because now we still have an issue. Even though we can simplify x minus 2 on the top and bottom, we still have a couple of them down here. So we really have the limit as x approaches 2 of 2 over x minus 2 squared. Now this is what's happening. Now whether I plug in a number lower than 2 or a number higher than 2, it's getting really close to 0, but it's also being squared. And negatives and positives, when they're squared, always go to positive. So that denominator is always going to be positive because it was squared. The numerator is just 2, so that's also positive. So it's going to be positive or positive. We're going to get 2 over a 0 essentially. But that really means it's going off to infinity. And it's positive over positive. So no matter if we're coming on the left side or the right side, it's going to be positive infinity. Wow, that was a lot. Alright, pause it if you need to, but I'm moving on. Alright, so we got some other stuff going on here. These are piecewise functions. And we were working on this in class, and one of the things that we're talking about is how do we even know what a piecewise function is? Well, the metaphor that we were looking at is it's kind of like prom tickets. You know, most schools do this thing where like the first week prom ticket is like 50 bucks. Then second week prom ticket is like 75, and it just keeps going up. And then you go to like 3 weeks later, and then we're at 80 kind of thing. So it's this piecewise function. It's split up into different pieces based on the various time interval. And the time intervals are like here. It's the second half of these functions. It's before one or after one. So we're really talking about prom tickets, you could say. Oh, let's get rid of that red mark there. It's not really a part of what we're doing. Okay, so now looking at this, that means that we can calculate what's going on. We need to look at the left side and the right side. So when we're calculating a limit, if it doesn't specify left or right, it really means both sides. The problem with this is that we have a left and a right. For example, when x is less than 1, that's left. That's the left of 1. And then when x is greater than or equal to 1, that's right of 1. Well, then let's see what's happening. The limit as x approaches 1, what do you want to do? Left or right? How about left? Left. From the negative side, below 1. That means that we're going to be doing the left one, down here, this function. Negative 2x minus 1. We can actually just plug that in because there's no zeros in denominators, so we're fine with calculating the numbers. That gives us negative 2 times 1 minus 1, which is equal to negative 3. Let's take a look from the right side. If we're looking from the right side, this time we're doing the right side. I'll underline this in blue. The right side is going to be this function here because we're on the right side of 1. So this limit as x approaches 1 from the right side is x squared minus 4 instead of the 2x minus 1. And we can evaluate that because, again, no zeros in the denominator, no zeros. That makes us happy. So that allows us to just plug it in. So that means we're going to have 1 squared minus 4, which equals negative 3 as well. Watch this. Oh, now we're super happy because look at that smiley face. Huge grin. We're super happy because the left equals the right. The left side equals the right side, which means the limits are kissing. They're not missing. Therefore, the limit as x approaches 1 from both sides is equal to negative 3. All right, let's check this next one. So we have x over x minus 2 and x minus 3 over x minus 2. Let's see what's happening. The split, first of all, is right here. It's at 2. So we got to figure out which one's the left side, which one's the right side. Well, this bottom one, this would be the left. And the top one, this would be the right, because it's greater than. So let's do the left first. Left side. That means it's going to be the limit as x approaches 2 from the left side. We're going to use this bottom function. Which is really x minus 3 over x minus 2. And if I plug this in, if I were to plug it in, I would get a number, which would actually be negative on top, a negative over 0. But I'm really interested in, as it's approaching that 0, is it a positive or is it a negative? Well, we're coming from the left side, so we got to be below 2, like 1.9. 1.9 minus 2 is really negative. So this is a negative down here. It's not 0. It's the approaching value is negative. Well, we have a negative over a negative, and that's going to give us a positive infinity. Why? Again, just to review, if you have a number divided by something really small like a 0, that's going to infinity. That's where the values are going. Let's look at the right side. The right side. Right of 2. So now we're looking at the limit as x approaches 2, but from the right, that's the positive. And on top, now we got to change functions here. Notice that when we're coming from the right side, it's a different function. It's going to be x over x minus 2. Similarly, we get a 0 on the bottom. We get a number over 0. And with that happening, we got to look at what's happening on top and bottom as far as positives and negatives. Well, if I'm picking a number slightly bigger than 2, so like 2.1, on top we're going to get positive, but on bottom 2.1 minus 2, are we going to get positive or negative? It looks like it's going to be positive as well. So those are going to positive infinity. That's where it's going toward. All right, so I have this value, it's going to be positive infinity. This other one is positive infinity. So what's the conclusion? Left equals right. They're both kissing, kind of. It's infinity, which isn't a number, but we'll say that it's a limit anyways. It's infinity in the positive direction. All right, we got one more here, and then you guys can take a break. So let's take a look at this. All right, we got a, whoa, ouch. My brain just cramped up on me because this thing, ouch, ouch. I look at those radicals, I'm like, how do I, ooh, that's different. I don't like radicals. Well, we'll learn how to deal with them here in a second. But let's go ahead and follow our procedure. First, plug it in, plug it in. It's the Glade procedure. You guys remember that? Plug it in, plug it in. All right. So we plug it in. Let's see what happens. It's going to be 0 plus 2 square rooted minus square root of 2 all over 0. Well, that means on top we get 0, and on bottom we get 0. So that means something's going to cancel. Something's going to reduce. We got to figure out a way to get the top and the bottom to simplify to 1 over 1. Well, there's a problem. It's not easy to look at this and say, oh, I'll just factor it. You can't really factor this that well. But I do know that it's these radicals that's giving me an issue, and I wish I could just square them away. But something you got to realize, like if I have the square root of a minus the square root of b like this, and I just square them, that does not equal a minus b. That's not what we're going for. But this does kind of clue us into something that we're looking for. If I could square those, if I wanted it to be a squared and b squared, then it would say something like a squared minus b squared. Well, hey, that's interesting because I know something about a squared minus b squared. That actually factors. That becomes a plus b times a minus b. So what I see is I see two terms. I see a term a here. And I see a term b here. And there's a minus sign in between. So what I need to do then is fill in the a plus b next to it. And then they'll be squared. So in other words, I got to fill in an a plus b here. So I got to have square root of x plus 2 plus square root of 2. And you can't just multiply by whatever you want in algebra, in any type of math. You got to multiply by 1 to maintain equality. You don't really change the value. So that means we just multiply by the same thing over itself. And you're probably asking yourself, man, that's going to make this bottom kind of messy. But a little trust should be what you have right now because it is going to eventually simplify out. Well, let's see what happens. We got the limit as x approaches 0. With the top, that's really going to become, we have a plus b times a minus b. So we're going to have a squared minus b squared. That's the square root of x plus 2 squared minus the square root of 2 squared all over this mess in the bottom. X times square root of x plus 2 plus square root of 2. Let's see what happens. As we're looking at this now, these radicals, the square roots and the squares, are inverse operations, so they kind of undo each other. So this is going to simplify now to the limit as x approaches 0 of just x plus 2. Then we got just minus 2. And on the bottom we still got the big mess. Radical x plus 2 plus radical 2. Now we got some more simplifying. This is actually helpful. This plus 2 and this minus 2 cancel each other out. They make a 0. And then that x and x is going to do something too, but I don't want to jump ahead too far. I want you guys to take it one step at a time. By the way, we're going towards 0. Forget to write that there. Limit as x approaches 0 of x over x times radical x plus 2 plus radical 2. So now these x over x simplifies to just 1. And then now what do we do? Well, wait a second. Wait a second. We can plug in. Why? Because when I plug in that 0, it's not going to give me the 0 in the denominator because I reduced it. I simplified it right here. It's gone. Yes. So this is going to equal 1 over radical 0 plus 2 plus radical 2. Now if I simplify that more, that's really 1 over radical 2 plus radical 2. More simplified is 1 over 2 radical 2. More, well, that's really all you need. But let's say you're one of those anal old fuddy-duddies that don't like radicals in the denominator because you're still using a slide rule from back in the day. Yeah, look it up. Look up the history. That's the only reason you rationalize a denominator. Then it's going to be times square root of 2 over square root of 2. Then we get square root of 2 over 4. Okay, so this answer is probably fine and acceptable, but if you're doing a multiple choice test written by old fuddy-duddies, that one's probably what you would see. But they're the same number, by the way. Keep that in mind. All right. Break now. Bye.